Hello, and welcome to Moon Whisper Sleep, where science meets sleep and the universe becomes a lullaby of light. Maybe today has been a long day, or maybe you're simply the kind of person who loves to let the mind drift away into the night, among distant planets, silent moons, and the fragile sound of the cosmos breathing. Wherever you are, however tired your mind feels, tonight, this journey is for you. Let your breathing slow. Let your thoughts dissolve like stardust in the air. Let your body grow lighter, as if gravity itself has loosened its grip, and you begin to drift softly through the ocean of space. Tonight, we will travel through the 100 greatest mysteries of science, the questions humanity has pursued for centuries and still cannot fully answer. From the birth of the universe to the tiny particles vibrating in the void, from the first light of the stars to the faint electric current flowing through your brain right now, everything is a question, and curiosity itself is what has kept humanity awake. As you close your eyes, your brain emits a frequency of 8 Hertz, the same resonance as the Earth and the same pulse that hums quietly through the universe each second. Tonight, you'll discover why DNA can glow like tiny crystals, why human brainwaves can synchronize with planetary magnetic fields, how the smallest particles in the cosmos can exist in 2 places at once, why time only flows in one direction, why galaxies drift endlessly apart, and why even in the cold darkness, life always finds a way to begin, to recognize itself, and to look up to the sky and ask, where did we come from? And why do we exist? And why sometimes, in dreams, we seem to hear the universe remembering itself. Don't rush. You don't need to understand everything. Just float. Let the whispers of the stars guide you, and let the light seep into the quietest corners of your mind. We'll listen to the delicate winds from worlds far away, planets born from the same dust as Earth, where ancient light still travels through the dark, and every grain of dust, every beam of light, carries a secret about time, life, and ourselves. Feel how the universe still moves, gentle, vast, patient. Every breath you take is one small rhythm in that cosmic symphony. If your heart feels calm, if this stillness makes you smile, press subscribe and ring the tiny bell, so that each night the universe can find its way back to you through the soft whispers of Moon Whisper Sleep. And perhaps your single gentle touch will become a signal, helping someone awake in the dark. Find this place, a place to rest, to learn, and to be lulled by the universe, one soul at a time. Now, take a deep breath. Let go of everything the day has left behind, and allow me to guide you through the layers of space, where we don't just observe the universe, but begin to see ourselves in every one of its movements. Before there was light, before space and time, there was a moment so strange that human language can barely describe it. From nothingness, no matter, no energy, no space, a faint vibration appeared, a pulse of energy lasting only a fraction of a second, yet it created everything we know today. Physicists call that instant the Big Bang, but it wasn't really an explosion in space. It was the birth of space itself, not a flame, but the first light of existence. Within the first 10 to the power of -32 seconds, The universe expanded faster than light. That was the moment when nothing became something. And from that instant forward, every atom, every star, and even you have carried the echo of that creation. Before there were stars or planets, the universe was a sea of oscillating energy. Everything from photons to protons to electrons was a wave spreading outward. That world had no color, no sound, only quantum vibrations. The first music ever sung by the cosmos. Over time, those subtle ripples condensed into matter, then into nebulae, and finally into stars and planets. Everything around you, the chair, the wall, your body, was once part of that ancient wave. About 380,000 years after the Big Bang, light was finally freed. Before then, the universe was so hot and dense that light could not escape. But as it expanded and cooled, protons and electrons combined into atoms, and suddenly, light shone freely for the first time. That light still exists today. It's called the cosmic microwave background, the afterglow of creation. It surrounds you even now, hidden in every radio signal and in every image captured by telescopes. When you gaze at the night sky, each star you see is not just the present. It's the past, billions of years old, still reaching for you. As the universe continued to expand, scientists noticed something strange. Instead of slowing down, the expansion was accelerating. An invisible force was pushing galaxies apart. We call it dark energy. No one knows what it is, only that it makes up 68% of the universe. If dark energy is the unseen hand, pushing the stars away, then dark matter is the hidden grip that holds galaxies together. Two invisible forces, one pulling, one pushing, govern everything we know. And humanity, standing between them, is still learning how to listen. From the first moment light appeared, the universe began telling its story. But for billions of years, it had no listener, until one day, a small creature on a blue planet looked up at the sky. Us, we are not only made of stars, we are the consciousness through which the universe observes itself. Every question we ask about origins, about time, about life, is another note in the cosmic symphony. If the universe began with a great explosion, its deepest secrets lie in the smallest of places. The world of particles, electrons, photons, quarks, follows none of the ordinary rules. A single particle can exist in two places at once. An object can both exist and not exist until someone observes it. This is the realm of quantum mechanics, where reality is not fixed, but a wave of possibilities. When you look at a grain of sand, it seems tiny, but if you could shrink yourself 1 billion times smaller, you'd see another universe, where the laws you thought were true completely collapse. It's a world where matter is not solid, where lines blur into probabilities, and substance becomes the dance of energy. In the early 20th century, physicist Max Planck discovered that energy doesn't flow continuously, but in discrete packets called quanta. That discovery opened the door to quantum mechanics and changed our understanding of reality forever. In this world, nothing is certain. An electron can exist in two places at once. A photon can be both a wave and a particle, depending on whether you're watching. Everything becomes real only when it's observed. As physicist Niels Bohr once said, reality does not exist independently of observation. What does that mean? That the universe only becomes real when a consciousness is there to perceive it? When scientists looked deeper, they discovered something astonishing. Everything around us is mostly empty space. The table, the wall, your body, all made of atoms, and over 9% of each atom is void. The only reason you feel solidity is because of electromagnetic forces between electrons. They never truly touch, only repel each other. So the world you live in may be nothing more than a symphony of forces and waves. If you could see with quantum eyes, you'd realize everything around you is shimmering, vibrating endlessly, like an infinite lake, rippled by billions of waves. In this realm, particles do not follow fixed paths. They vanish and reappear in different places, as if teleporting. An electron doesn't orbit like a planet. It exists in a probability cloud, a region where it might be found. Quantum mechanics doesn't describe where a particle is, only where it could be. That means, at the most fundamental level, the universe isn't a chain of certainties, but a map of possibilities, waiting to be chosen. And the observer, you, are the one who activates that choice. One of the most astonishing discoveries in science is that when we look deep enough, we no longer find matter. We find energy, and deeper still, information. Every particle, every photon, carries data as if the universe were an immense code, and everything exists because it contains information. Physicist John Wheeler called this idea it from bit, meaning existence arises from information. In that sense, the universe is not a machine made of matter, but a continuous stream of data, being processed moment by moment, and human consciousness may just be the instrument that reads that data. When you sit quietly, eyes closed, your brain never stops broadcasting signals. Billions of charged particles, sending information through the dark. Those electrical pulses at the quantum level follow the same strange rules as electrons and photons, which means that in every breath you take, your mind functions like a tiny universe where particles appear, disappear, and are born again. You are not just living in the universe. A part of the universe is living within you. The quantum world is like the first mirror the universe used to look back at itself. It does not give us definitive answers. It makes us ask deeper questions. If a particle only chooses a position when it is observed, and if consciousness is what brings reality into being, then does the universe exist only because we are looking at it? That question is the beginning of all the mysteries science is still tracing. The deeper we look into the microscopic world, the more we realize reality is not what we see. It is a mirror reflecting our own mind. Imagine you are standing in a dark room. In front of you is a metal wall with two narrow slits, and behind it, a white screen. Now we fire tiny particles through it. They could be photons, electrons, or even atoms. What you expect to see are two bright bands. like two little bullet marks hitting the wall. But when physicists first performed that experiment in the 19th century, they saw something entirely different. On the screen, there were not two bands, but a series of alternating light and dark stripes, like the pattern formed when water waves interfere with each other. That can only happen if those particles behave like waves. An electron is, physically speaking, a particle. It has mass, charge, and can be measured. Yet when we are not observing it, it spreads out like a wave of probability. It does not go through the left slit or the right slit. It goes through both slits at once. It does not choose one path. It chooses every path it can. That is why, when thousands of electrons are fired, they overlap and create an interference pattern. This stunned the physical world, because it is not only about electrons, it is about reality as a whole. Scientists decided to place a detector to see which slit the electron actually goes through. And the result, when there is observation, the interference pattern disappears. The electron no longer goes through both slits. It chooses a single slit, behaving exactly like an ordinary material particle, simply because someone is watching. No one changed the physical conditions. No one touched the electron. The mere intention to observe and the outcome of reality was different. This experiment has been verified hundreds of times with photons, electrons, C60 molecules, and even helium atoms. The result is always the same. When unobserved wave patterns appear, when observed, the wave pattern collapses into particles. This phenomenon does not mean human consciousness creates reality, but rather the act of measurement forces a quantum system to choose a specific state. When there is no measurement, a particle exists in a state of superposition, both wave and particle, both here and there. But when the measurement occurs, the probability wave function collapses to a single outcome. That is what made Einstein exclaim, "Does the moon exist only when I look at it?" That question is not merely philosophy. It is a foundational problem of quantum mechanics. Does objective reality exist, or does it only appear when it is measured? Today, most physicists agree that this phenomenon does not necessarily require human consciousness. It only requires a physical interaction sufficient to record information. When a photon collides with a sensor, the quantum system loses its independence, and that is the act of observation. This process is called decoherence. It transforms the ambiguous world of probabilities into the concrete world we see. But the deeper question remains. If everything only chooses a form after being measured, then before that, in what form did the universe exist? An unshaped sea of possibilities, or a reality waiting for the observer to open their eyes? The double-slit experiment is the foundation of modern quantum physics. From that principle, we have quantum computers, quantum cryptography, and ultra-precise measuring devices based on wave interference. It shows us that matter is not as rigid as we once thought, but energy that can be influenced by information. It reminds us that observation is not just a passive act, but part of the universe's creative process. And, deeper still, it evokes an almost meditative insight, that when we listen, we change what is heard. When we look at the universe is also looking back at us. The universe doesn't exist without an observer. John Archibald Wheeler. When scientists fired electrons one by one through two narrow slits, they expected to see two impact bands. But no, electrons created an interference pattern, like water waves, not solid particles. And then, when they placed a detector, the interference pattern vanished. Electrons behaved like particles again, just because someone was watching. What does that mean? Could consciousness influence reality? Does the universe only choose its form when someone is observing? That is the question that, to this day, no physicist dares to answer definitively. Einstein called it spooky action at a distance, a phenomenon so strange that even the greatest genius of the 20th century felt uneasy. It begins with something seemingly simple. Two particles are born at the same time. For example, two photons emitted from the same source of light. They become quantum entangled. This means their states are no longer separate, but become a single system, even if they are later taken arbitrarily far apart. When you measure one particle, the other responds instantly, even if they are billions of kilometers apart. No signal, no delay, only instantaneous synchronization. In 1935, Einstein and two colleagues, Podolsky and Rosen, put forward an argument against quantum mechanics known as the EPR paradox, Einstein-Podolsky-Rosen paradox. He believed there cannot be any instantaneous influence faster than the speed of light, because according to relativity, light is the ultimate limit of information transmission. Therefore, Einstein argued, there must be hidden variables, information concealed within the particles, that determines the outcome, even before we measure it. But 40 years later, in 1964, physicist John Bell proved that if there are local hidden variables, then experiments would not yield the results predicted by quantum mechanics. And when hundreds of experiments were conducted thereafter, culminating in tests with photons, ions, and electron spins in the 1,980 seconds, 2,020 seconds, the results all indicated Einstein was wrong. There are no hidden variables. There is no classical way to explain this phenomenon. The two particles truly remain instantaneously linked beyond space. Today, quantum entanglement is no longer merely mysterious. It is applied in technology, quantum communication, quantum encryption, quantum computers. For example, in experiments in China and Europe, pairs of entangled photons have been transmitted over distances of more than 1,200 kilometers from the Messier satellite in orbit down to two separate ground stations. When measured, they remained perfectly synchronized. There was no wire connecting them, only an invisible bond beyond time and space. Some physicists, such as David Bohm, believe that entangled particles do not transmit information to one another, but rather share the same underlying state at a deeper level of reality. Like two waves rising from the same ocean, they seem separate, but in truth, they are one. At the deepest level, every particle in the universe may have once been connected, born together in the moment of the Big Bang. If so, everything in the cosmos remains connected, just at a level beyond what our senses can perceive. When scientists talk about quantum entanglement, They are not talking about spirituality, yet this very phenomenon suggests a new way of thinking about consciousness and connection. The human brain contains billions of neurons. When two people communicate, their brain waves can partially synchronize through faint electromagnetic signals. Though this is not the same as quantum entanglement, it raises a profound question. Could the synchronization of consciousness be a biological reflection of the universe's quantum entanglement? Science has no answer yet, but it reminds us of something essential. In a universe where every particle was once connected, perhaps loneliness is only an illusion. Quantum entanglement doesn't just challenge logic, it challenges our deepest intuition. It tells us that distance is no longer a limit, and separation is merely an illusion. When you touch a particle of light, perhaps somewhere across the universe, another photon trembles at the same frequency. Just as when you breathe slowly, the entire Earth, from its magnetic field to its biological rhythms, vibrates in harmony at 8 Hertz. Maybe everything in the universe beats to the same rhythm. We simply haven't learned how to listen yet. In entanglement, the universe remembers that it was once one. If you could see each electron moving inside your body, you'd discover a paradox that feels impossible. They are both waves and particles, and what they choose to be depends entirely on how you observe them. This is one of the most fundamental principles of quantum physics, the wave-particle duality. It tells us that every particle of matter, from the tiniest photon to the largest carbon molecule, it can also behave as a wave of energy. According to Schrödinger's equation, 1926, a wave function can describe each particle psi, which expresses the probability of finding that particle in a specific place. This is not a theory. It has been confirmed through thousands of experiments. When you do not measure a particle, it doesn't exist in one fixed position, but in countless possibilities at once. It could be here, or there, or everywhere in between. That state is called quantum superposition, a kind of dream between realities, where the particle hasn't chosen its shape and all possibilities coexist. To help the world grasp this, Erwin Schrödinger imagined a strange thought experiment. A cat sealed inside a closed box with a vial of poison that would break if a radioactive atom decayed. According to quantum mechanics, until we open the box, the atom is both decayed and not decayed. And since the cat's fate depends on it, the cat is both alive and dead. It's not a joke. It was Schrödinger's way of forcing us to face the paradox of reality itself. Until we observe it, the wave function of the system exists in an infinite number of possibilities. But the instant we open the box, all possibilities collapse into one single outcome. A single act of looking can change the entire universe. The astonishing thing is this: the same principle applies not only to subatomic particles. It forms the foundation of everything in nature. The light you see, the sound you hear, even the memories and dreams in your mind are all made of energy quanta that constantly shifts between wave and particle. When you are not looking, they are gentle vibrations in a field of energy. When you pay attention, they take form as images, sounds, or emotions. So the world around you is not a static wall, but a river of probabilities, changing every second. Today, quantum physicists believe that reality is not a final product, but a living process. The universe is not a pre-built stage, but a symphony that only begins to play. When the listener arrives, wave and particle are not opposites. They are two faces of the same essence, one of energy, the other of form, a constant oscillation between the invisible and the visible. Reality is not made of things, but of possibilities. Werner Heisenberg. So when you look up at the night sky, the light you see may have begun its journey millions of years ago, and only when it reaches your eyes does it choose the moment to become real. You are not just looking at the universe, you are completing it with your gaze. Take a deep breath. You, I, and every photon of light are vibrating together in the same ocean of energy. And within that vibration, we learn that reality is not fixed. It is as flexible as the mind that perceives it. If the quantum world once bewildered Einstein, the next question went even deeper. How can it be reconciled with his own theory of relativity? Because on one side stands quantum mechanics, the ruler of the tiny, where uncertainty and probability reign. On the other stands general relativity, the law of the vast, where space-time bends under gravity. Both are true. Both are proven by experiment. Yet when we try to unite them, every equation breaks apart. In the macroscopic world, time flows linearly, with causes preceding effects. But in the quantum world, a particle can choose its result before the cause even happens. In delayed choice experiments, photons seem to know in advance whether they will be measured as a wave or as a particle and adjust their behavior accordingly. Even when the decision to measure is made after they've passed through the slit, reality appears to anticipate the future. It doesn't break physics. It simply shows that we still don't understand the true nature of time. And then we come to black holes, where all equations fail. Inside them, density becomes infinite, and time stops. If you were to fall into a black hole from the outside, you would never reach the center. But from your own perspective, the entire future of the universe would pass in a single instant. Two versions of time coexisting, both true. Quantum and relativity, like two mirrors facing each other, forever reflecting, never touching. From Einstein to Schrödinger to Hawking, they all searched for the theory of everything, a single framework that could describe all things, from the smallest particle to the vastness of the cosmos. Many believe the answer may lie in string theory, where every particle is not a point, but a tiny vibrating string of energy, its frequency determining its form. An electron may simply be a string vibrating at one frequency, a photon at another, and the entire universe, a grand symphony of countless strings resonating within 10 hidden dimensions of space. Though not yet fully proven, string theory opens a vision. Everything from light to consciousness is simply different vibrations of the same source of energy. We may not understand it all yet. Perhaps the equations are still missing half a chapter. But within that not knowing, humanity finds beauty. Because science is not a collection of answers, but the art of asking questions. The universe may not need us to exist, but our desire to understand it is what gives it meaning. And at the delicate boundary between knowledge and mystery, we realize what matters is not knowing everything, but remaining curious. Somewhere, something incredible is waiting to be known. Carl Sagan. If the universe has a heart, then the black hole is at its slowest, deepest beat. Nothing in the cosmos is stranger than a black hole, a place where matter, energy, and even light are drawn in, so completely that nothing can escape. No ray of light, no signal, no whisper. A black hole is not just a dark region in space. It is a dent in the very fabric of spacetime. Every black hole begins with a death. When a massive star burns through its fuel, its core collapses under its own weight. Gravity prevails. The star contracts so rapidly that nothing can halt it. Every atom, every proton, neutron is crushed to infinite density. When that mass is concentrated into a single point, the curvature of spacetime becomes extreme and a black hole forms. That is the singularity, where all the equations of physics we know break down. Space is bent, time stops, and the boundary surrounding it is called the event horizon, a place from which even light cannot return. If you cross that line, every exit disappears. No return, no signal, only absolute silence. In the universe, gravity doesn't just pull matter, it also pulls time. According to Einstein's general relativity, 1915, gravity is not an invisible force, but the curvature of space-time is caused by matter. The closer you are to a massive object, the slower time passes. If you orbit a black hole, you would see your clock run very slowly, while far away, everything proceeds as usual. This has been verified many times, from GPS satellites in orbit to the first image of the black hole M, 87 times captured by the EHT in 2019. The nearer you approach the event horizon, the more time dilates without bound. From the viewpoint of an outside observer, you would freeze at the boundary, but for you, you continue falling forever. In the realm of black holes, time is no longer a flow, but a standing ocean. Stephen Hawking once said, "Black holes are not entirely black." According to quantum mechanics, the vacuum is filled with virtual particle pairs. A particle and its antiparticle constantly appearing and annihilating. If this happens right at the edge of a black hole, one particle can fall in and the other escape, carrying away a bit of energy. This phenomenon is called Hawking radiation. It means a black hole emits a faint glow, and over unimaginably long times, trillions upon trillions of years, it will gradually evaporate and vanish completely. The death of a black hole is as quiet as its birth. But Hawking also posed a question that shook physics. What happens to the information that falls into a black hole? According to quantum mechanics, information cannot be destroyed. It can only be transformed or hidden. Yet when an object falls into a black hole, all its data position, energy, structure seems to disappear forever. If that were true, the foundations of physics would collapse, for the universe would lose its ability to remember the past. To address this, a new hypothesis emerged. Perhaps information does not vanish, but is encoded on the surface of the black hole. That surface, the event horizon, acts like a vast screen, recording everything that has ever fallen in as minuscule quantum fluctuations. This is the basis of the holographic principle, that the universe may be a three-dimensional projection of data stored in two dimensions. If this hypothesis is correct, then the entire world you see, every star, planet, memory, and even you, may be a quantum projection of a deeper, flatter reality hidden just beyond the reach of human understanding. Many physicists believe that within a black hole there may exist an Einstein-Rosen bridge, also known as a wormhole, a tunnel connecting two different regions of spacetime. Though unproven, the idea opens a beautifully poetic possibility that a black hole is not death, but a doorway to another universe. Some mathematical models even suggest that on the other side of a black hole, there could be a white hole where matter is not pulled in, but expelled outward. If so, all that falls into darkness might be reborn as light elsewhere. When you look at a real image of a black hole, a ring of fiery orange encircling an abyss without end, you are not just seeing physics at its extreme. You are witnessing the meeting of light and darkness, of the visible and the ineffable. Inside, all rules dissolve, but at the edge, light bends itself into perfect beauty. Perhaps a black hole is not merely the destroyer of stars. It is the keeper of the universe's memory, where time stops so that every story can begin again. Maybe the universe hides its most beautiful truths in the darkest places. Jupiter is the largest planet in the solar system, so vast you could fit more than 1,300 Earths inside it. It is a star that almost was. If its mass were 80 times greater, Jupiter would have been heavy enough to ignite nuclear fusion and become a second Sunday. Its atmosphere is a blend of hydrogen and helium, like the unburned core of a star that never fully lit. The brown, orange and white bands across its surface. There are colossal streams of gas circling the planet, forming the Great Red Spot, a storm at least 350 years old, larger than Earth. Beneath those clouds, pressure rises so high that hydrogen is squeezed into liquid metallic form, a silvery ocean surrounding the core. From this, Jupiter generates the strongest planetary magnetic field, enveloping it in a vast radiation belt, the magnetosphere about 20,000 times stronger than Earth's. Thanks to its immense gravity, Jupiter acts as Earth's protector, capturing or deflecting countless comets and asteroids. Without Jupiter, our blue world might have been wiped out hundreds of times. In the darkness of the universe, a giant stands guard over us in silence. If Jupiter is the symbol of power, then Saturn is the symbol of grace. Its rings are among the most breathtaking sights ever seen through a telescope. They are made of billions of fragments of ice and rock, orbiting the planet in perfect harmony. Each particle reflects sunlight, like a crystal. Though the rings are only about 10 meters thick, they stretch over 280,000 kilometers, nearly 3/4 of the distance from Earth to the Moon. Spacecraft such as Voyager, Cassini, and Huygens have sent back magnificent images, hexagonal storms swirling at the North Pole, sound waves echoing through the rings, and sunlight glinting across the planet, making it glow in the night. Beneath the pale golden atmosphere are layers of hydrogen, helium, and ammonia. Saturn's core may be a mix of rock and ice, with temperatures reaching tens of thousands of degrees Celsius. And though it looks massive, Saturn is the least dense of all planets. If there were a vast enough ocean, it would float upon the water, but even beauty fades. According to NASA, Saturn's rings are slowly disappearing, losing about 100 tons of material every second, and could vanish entirely within 100 million years. No beauty is eternal, not even one that belongs to the stars. Uranus is the strangest planet of all. Its axis is tilted by nearly 98 degrees, lying almost completely sideways as it orbits the Sunday. No one knows exactly why. The leading theory suggests that billions of years ago, a massive Earth-sized body collided with it, tipping the planet over and causing its poles to take turns facing the Sunday. This created seasons that last for decades. Half the planet stays in sunlight for 42 years, while the other half remains in darkness for the next 42. Its surface glows turquoise blue. Methane gas absorbs red light and reflects blue. Temperatures in its upper clouds drop to 224 degrees Celsius, the coldest in the solar system. Yet despite that cold, Uranus possesses a tilted magnetic field and fierce winds, racing at up to 900 kilometers per hour. These winds don't flow along the equator. They swirl in reverse across its slanted rings, as if the planet were spinning inside a dream of its own. The farthest of the four gas giants is Neptune. It lies more than 4.5 billion kilometers from the Sun, receiving so little sunlight that its daytime is like twilight on Earth. And yet, paradoxically, Neptune has the strongest winds in the entire solar system. Its storms can reach speeds of 2,000 kilometers per hour, faster than the speed of sound on Earth. This violence is driven by the vast temperature contrast between its hot, pressurized interior and its freezing outer layers. Deep within, pressure grows so immense that carbon atoms may crystallize into diamonds and fall as rain. Scientists believe that Neptune and Uranus might even host liquid diamond oceans, where carbon crystals sink, melt, and swirl in shimmering blue depths. Its faint rings, its vast dark storms, and its ghostly blue glow make Neptune appear like a dream, drifting at the edge of the universe. Voyager 2, the only spacecraft ever to visit Neptune, departed in 1989, and no one has returned since. But whenever the Hubble Space Telescope turns its gaze there, we still see that silent blue flicker, as if a distant world were whispering back. There are places in the universe that, though no one visits anymore, still breathe and dream. When you look up at the night sky, the light reaching your eyes doesn't come only from the stars. It comes from the past. Every beam of light is a fragment of time, beginning its journey millions, even billions of years ago, traveling across space, through cold, dark regions, and only now, upon touching your eyes, does it complete its mission to tell the universe's story. Light is pure energy. In the language of physics, it is called a photon, a fundamental particle with no rest mass, moving always at 299,792 kilometers per second, the ultimate speed of matter and information. Photons need no medium to travel. They move through the vacuum, through space-time itself, carrying with them the universe's message. When a photon meets matter, it can be absorbed, reflected, or bent. Those collisions create color, and through them, we perceive the world. Every color you see, from red to violet, is merely a different vibration of photons with wavelengths between 700 and 400 nanometers. All light, all color, is simply different notes in the same symphony of energy. Before the first stars ignited, the universe was a blazing ocean of plasma, a soup of protons, electrons, and photons moving freely. When the universe cooled, about 380,000 years after the Big Bang, electrons combined with protons to form hydrogen atoms. Photons were released, and from that moment, the first light began its free voyage. That ancient light still exists today. We call it the cosmic microwave background, CMB. It continues to surround us, hidden as a faint microwave glow, only 2.7 Kelvin above absolute zero. Astronomers have captured this signal using the Planck telescope. When they transformed it into an image, it became the oldest map of the cosmos, a portrait of the newborn universe, vibrating with the first breath of space itself. Every star, every planet, every cloud of dust sends its own light into the cosmos, and that light carries information about its origin. By analyzing a star's spectrum, splitting its light into distinct wavelengths, scientists can learn which elements it contains, how hot it burns, and how many light years away it is. A single streak of light in a telescope can tell a story millions of years old. Light is the universe's most faithful storyteller. It never forgets. It simply keeps traveling, carrying every memory ever released. When we see light from a star, 10,000 light years away, we are witnessing it as it was 10,000 years ago. That star may already have vanished, yet its light continues to journey onward, and in this very moment, it touches your eyes, a message sent from the past. According to Einstein's theory of relativity, light doesn't just travel through time, it defines time. For a photon, distance and time do not exist. From its perspective, the instant it leaves its source and the instant it reaches your eye are one and the same. In other words, a photon that left a star billions of years ago and arrived on Earth today, for it, that was a single heartbeat. The more we understand this, the more we realize that light does not merely move through space. It weaves every moment of the universe together, from the first explosion of creation to the instant you switch on a lamp in the dark. Every beam of light is another pulse of the same eternal being. Light not only lets us see the world, it creates life itself. On Earth, sunlight nourishes plants through photosynthesis, producing the oxygen we breathe. Light also governs our circadian rhythm, telling us when to wake and when to sleep. And in the brain, every photon that passes through the retina is transformed into electrical impulses, traveling through over 100 billion neurons until finally becoming aware of sight. as if the universe were shining through our eyes, just to gaze upon itself. We do not merely see light. We are light slowed down enough to become aware of itself. When you turn off the light and lie down, don't think it has disappeared. It is simply continuing its journey through the veil of night, across billions of light years, until one day, another pair of eyes, somewhere far away, will open and see the same beam you are dreaming of now. Light never dies. It only continues its story, in different forms. In this universe, everything can change. Stars are born and fade. Planets spin in the dark. Even space itself is expanding every second. Only one thing never changes: the speed of light. In 1905, Albert Einstein published Special Relativity, in which he established an invariant limit for the entire universe. Nothing can move faster than light, that is 299,792,458 meters per second. That is not just a number, but the boundary of reality. Because the closer you move toward that speed, the more everything around you begins to change. Time slows down, space contracts, mass increases. If you could fly at 99% the speed of light, time for you would pass more than 7 times slower than for someone on Earth. The faster you go, the slower time becomes. And if hypothetically you reached the speed of light, then the time for you would stop entirely. The moment of emission and the moment of arrival would occur simultaneously. That is why the photon, the particle of light, has no experience of time. From its perspective, the entire journey across the universe is a single instant of being. When an object with mass moves, the energy required to accelerate it increases with the square of its velocity. According to Einstein's famous equation, E m², energy, E, and mass mole can be exchanged for one another. The closer you get to the speed of light, the more colossal the energy needed to keep accelerating, until it becomes infinite. That means no object with real mass can reach or exceed the speed of light. Only photons, particles with no rest, mass, can travel at that speed and keep it forever. In the language of the universe, light is the boundary of possibility. One of the most marvelous consequences of this limit is time dilation. In 1971, American physicists flew 2 atomic clocks on jet aircraft around the Earth and compared them with a clock that remained on the ground. When they returned, the airborne clock had indeed run slower by a few billionths of a second, exactly as Einstein predicted. Speed changes the rate at which time flows. If you could board a ship flying near light speed, travel for 10 years, then return to Earth, you might have aged only 10 years, but hundreds of years could have passed on Earth. That is not fiction. It is a mathematically derived and experimentally confirmed result. The universe truly bends time to protect the limit of light. Thanks to that limit, we can measure cosmic distances in light years. The distance light travels in 1 year, nearly 9.46 trillion kilometers. When we say Alpha Centauri is 4.3 light years from Earth, we mean it takes more than 4 years to reach our eyes. That is also why every astronomical observation is a look into the past. The more powerful the telescope, the deeper we see into the universe, and the farther back we look in time. The images from the James Webb Telescope today are light emitted over 13 billion years ago, from when the first galaxies began to shine. Not only is it a boundary, the speed of light is the foundation of all physical laws. Every force, every particle, every fundamental interaction obeys this speed, from electromagnetism, gravity, to neutrinos. If the speed of light changed by even 0.1%, the universe could not have formed as we see it today. Stars would burn too fast, atoms would be unstable, and life could not exist. That limit is not a shackle, but a perfect balance. Fast enough to carry energy, slow enough for the universe to have time to evolve. Light is not just fast. It is the rhythm by which the universe breathes. Light is not only the fastest thing, it is the heartbeat of reality. Everything, from the smallest particle to the largest galaxy, exists within the bounds it sets. When you see a beam of light, you are looking at the ultimate boundary, to which both space and time bow. In the universe, light does not merely move, it sketches the shape of space. Since Einstein announced general relativity, 1915, we understand that gravity is not an invisible pull, but the curvature of space-time. And light, the fastest traveler, is the very thing that reveals that curvature. When light passes near a massive object, like a star, a planet, or a black hole, its path is bent. This phenomenon is called gravitational lensing. Einstein predicted it, and in 1919, astronomer Arthur Eddington confirmed it during a total solar eclipse. Starlight from behind the sun was indeed deflected as it passed through the sun's gravitational field. From that moment, we knew that light does not travel in a perfect straight line, but follows the shape of curved space. If space is flat, light goes straight. If space is curved, light curves with it. And because light is the fastest, it is the perfect compass for measuring the universe's curvature. Imagine space-time as a gigantic elastic sheet. When you place a heavy object upon it like the sun, the sheet sinks, and smaller bodies like the Earth move around that depression like a marble circling a deep groove. There is no true pulling force. There is only motion within curved space. Light, always following the shortest path, slides along that curvature. When it passes by a massive galaxy, light can be bent so much that it forms a ring of light around the source, what we call an Einstein ring. Images from the James Webb or Hubble telescopes have captured countless such halos where a distant galaxy is duplicated by the gravity of another. The universe turns itself into a mirror to see its own face. Not only does gravity bend light, it bends time itself. The closer you are to a massive object, the slower time flows. This is the phenomenon known as gravitational time dilation. Scientists have measured it using atomic clocks, one clock placed on the ground and another raised just 30 centimeters higher. The one above actually runs faster by a few billionths of a second each year. On Earth, the difference is tiny, but near a black hole, it becomes extreme. If you were orbiting a supermassive black hole, 1 hour for you could equal 7 years on Earth. This was depicted with scientific precision in Interstellar, and it was based entirely on Einstein's real equations. Because light always follows the shortest path, it is also the most precise measure of time. Modern atomic clocks measure time by counting the oscillations of photons in a cesium atom. No, 192, 630, 1770 oscillations per second. Every technology, GPS, satellites, data transmission, relies on the speed and stability of light. Without light, we could not measure time, could not know distance, and could not see our own past. The deeper we observe, the clearer a quiet truth becomes. Light and time are inseparable. One is a flow, the other a rhythm. Together, they form the heartbeat of space-time. So when you gaze at the night sky, don't think you're seeing the light of the past. You're watching time itself, moving in the form of light. Light doesn't just show us time, it is time, moving through space. Every beam of light you see has traveled for billions of years, through cold darkness, just to arrive here, to touch your retina and become awareness. When a photon strikes your retina, it activates photoreceptor cells, cones and rods, transforming the energy of light into electrical signals. These signals travel to the visual cortex, where your brain interprets them as images. That means you don't truly see with your eyes. You see with your brain, through light. Light doesn't just illuminate objects, it illuminates the mind. Every color, every image is the transformation of photon energy into consciousness. Without light, life as we know it could not exist. Green plants absorb sunlight and convert it into energy through photosynthesis, producing oxygen, the source of breath for all living beings. Even our biological rhythm is governed by light and darkness. When the sun rises, blue light stimulates cortisol, helping us wake. As night falls, the absence of light triggers melatonin, helping us sleep. Thus, light doesn't just create life, it regulates its rhythm. Every photon that once left a star, after billions of years of travel, still carries its original energy and direction. It holds the memory of where it was born, and when it reaches you, that memory continues. You're not just looking at a star, you are looking through the eyes of the universe, watching itself shine. When you look at light, you are the universe remembering itself. Modern neuroscience suggests that consciousness may be understood as a complex electromagnetic vibration within the brain. Those oscillations, though faint, are essentially light waves at very low frequencies. The brain emits gamma waves, 40 Hz when focused, and alpha waves, 8-12 Hz, during relaxation or meditation. These are slow vibrations of light that can synchronize with Earth's electromagnetic rhythm to 8 Hz. That means, in moments of stillness, your brain resonates with the planet's field of light. When you close your eyes, light doesn't vanish, it simply turns inward. From the ancient photons of the early universe to the light passing through your retina today, it is all one continuous stream of energy, flowing without interruption. Perhaps human consciousness is simply light becoming self-aware, light seeing itself and calling it I. So when you relax and let light flood your mind, you are listening to the deepest language of the universe. We are not observers of light. We are its continuation. When you glance at a clock, the second hand moves steadily. Each new moment is born, and the one before it quietly fades. We are all drifting upon a river no one can swim against. Time. In physics, nothing in the equations forbids time from running backward. The laws of Newton, Maxwell, even the Schrödinger equation are all time symmetric. If we reversed everything, the equations would still work perfectly. But in reality, the world operates in only one direction. A glass shatters. It never reassembles itself. You grow older. You never become younger. This is explained by a central concept in physics: entropy, the measure of disorder in a system. According to the second law of thermodynamics, entropy in a closed system always increases with time. The universe moves from order to disorder, from concentrated energy to dispersed energy. And it is this increase in entropy that defines the arrow of time. Imagine dropping a drop of ink into a glass of water. At first, the ink is concentrated, that is order, but within seconds, it spreads everywhere disorder. Entropy has risen. No law compels it to return to its original form. Thus, the past is order that has dissolved, and the future is disorder waiting to happen. The arrow of time points in the direction that entropy increases. It's not a spiritual idea. It's a natural statistical outcome. From the decay of radioactive atoms to the fading of stars, every process in the universe follows this path. From order to chaos, from concentrated energy to dispersion. When the universe was first born from the Big Bang, it was unimaginably hot, dense, yet highly ordered. Energy was packed into a tiny space, and entropy was at its lowest possible level. As the universe expanded, entropy began to rise. Matter clustered together, forming stars, planets, and life. Each star burns its fuel, releasing light, and eventually dies, returning energy to a more chaotic state. And that very process marks the passage of cosmic time. Time doesn't flow like a river. It manifests through the transformation of energy, and entropy is the compass pointing the way of that transformation. In the human brain, time is not something we measure. It is something we experience. When you are waiting, the brain records each second as a separate event. But when you are immersed in joy, the brain processes fewer changes, and time seems to pass quickly. Neuroscientists call this time perception, the sense of time that depends on how much neural activity changes and the level of entropy within the brain. When the brain processes more information, entropy rises quickly, and you feel time as long. When everything repeats and entropy is low, time shortens. This means that the human brain perceives time through the very chaos of its own information. We don't just live in time, we create time within ourselves. According to general relativity, time is not a universal river shared by all. It stretches or contracts depending on speed and gravity. When you move quickly, your time slows relative to someone standing still. When you are near a massive object, for example, close to a black hole, time also slows down. In 1971, physicists Hafele and Keating flew atomic clocks around the Earth on airplanes. When they returned, The airborne clocks were indeed slower than those left on the ground, exactly as Einstein had predicted. Thus, time is not a shared current. Each person, each object, has its own flow of time, shaped by the energy and gravity it experiences. In quantum equations, the past and the future can exist simultaneously. Particles may move in both directions through time, and only when we observe them does the direction collapse. Some physical models, like the block universe theory, suggest that the entire past, present, and future all coexist. We are simply experiencing one slice at a time. If you could view the universe from outside, every moment, from the Big Bang to the final collapse, would already be written like frames in a completed film reel. We are merely passing through each frame 1 second per second. This does not deny free will. It only suggests that time itself does not move. We move through it. Today, the universe continues to expand, and cosmologists predict that entropy will keep increasing until it reaches its maximum. The heat death, that is the moment when all stars fade. All black holes slowly evaporate via Hawking radiation, and no energy differences remain to drive motion. At that point, all processes will stop. There will be no before or after. Time in its essence will end. But end does not mean disappear. Time will no longer be an experience of change, but a state of perfect stillness in energy, a static universe, neither cold nor hot, neither moving nor still, only perfect equilibrium. Time is not only the river of the cosmos, it flows within every heartbeat. With each inhale and exhale, you exchange energy, increase the world's entropy slightly, and preserve your small island of order. You, like every living being, are a local reversal of entropy. Your body resists chaos by consuming energy, keeping itself briefly more ordered than its surroundings. But one day, when your energy disperses back into the cosmos, you will also merge with that endless current of entropy. Nothing is lost. Nothing truly stops. Only energy changing form. Perhaps time exists because energy needs a way to remember. Every change is a trace, every motion a memory. Without time, the universe could not know that it exists. But without energy, there would be nothing for time to measure. The two are intertwined, like light and shadow. One defines, the other records. Time is how the universe remembers its own motion. When you close your eyes and let your mind drift, you temporarily step outside the feeling of time. Your brain shifts into alpha waves, 8 hertzes, a frequency that matches the Earth's own resonance. In that state, entropy in the brain decreases, signals slow, and you begin to feel as if time disappears. It isn't an illusion, it is a primal sensation. The mind touching the region beyond change, where time pauses and only the pure energy of existence remains. Perhaps time isn't something that passes by us. It's something we create, moment by moment, to remind the universe that it's still alive. If time is a one-way river, then energy is the bloodstream of the universe. Every particle, every ray of light, every heartbeat, and thought is sustained by a single principle. Nothing truly disappears. In the 19th century, physicists like Helmholtz and Joule discovered that in every process, the total amount of energy remains constant. It can transform from light to heat, from motion to electricity, but it never vanishes. This principle, known as the law of conservation of energy, is one of the pillars of modern physics. From planetary orbits to atomic structure, everything follows this rule. Even when a star explodes in a supernova, the energy of that explosion does not disappear. It transforms into photons, neutrinos, and new matter. The universe wastes nothing. It only recycles its own infinite energy. In 1905, Albert Einstein wrote the most famous equation in history, E等于mc的平方. That simple formula states that energy and mass are two sides of the same reality. A small amount of matter can become an enormous amount of energy because c squared, the speed of light squared, is an immense number, 30万千米每秒, 等于9乘10的16次方. When the sun shines, it is converting hydrogen atoms into helium, and in the process, a tiny fraction of that mass becomes radiant energy. Just 1 gram of matter can release energy equivalent to 20 tons of TNT. Thus, matter does not die. It merely changes its form, from particle to wave, from light to consciousness, from star to human body. All are different expressions of the same eternal stream of energy. The first energy to ever touch Earth was sunlight, a stream of photons born from nuclear fusion. Every second, the sun releases about 3.8 times 10 to the power of 26 watts of energy, and only a tiny fraction of it reaches our planet. Yet that small fraction is the origin of all life. Green plants absorb photons through chlorophyll, transforming them into chemical energy via photosynthesis. The equation of life is written like this: 6CO2 plus 6H2O plus photon C, 6H12O, 6 plus 6O2. That is how sunlight becomes sugar, becomes oxygen, and finally becomes the fuel of every cell. You breathe, your heart beats, and every cell within you moves, thanks to solar energy stored in molecules of sugar. Light has become life, and when life fades, that energy returns to the universe, a cycle that never ends. The human body is a perfect biological power plant. Every second, thousands of chemical reactions occur inside your cells, converting ATP, adenosine triphosphate, into ADP, releasing energy so you can move, think, and dream. Each breath you take is an exchange between you and the universe. The oxygen you inhale burns glucose to create energy, and the carbon dioxide you exhale is the receipt of that process. On average, an adult human body continuously releases about 100 watts of power, like a small light bulb that never stops shining. The wonder is this: that energy never disappears. It simply transforms into heat, motion, brain waves, or thought. The human brain consumes about 20% of the body's energy, even though it makes up only 2% of its mass. Every thought, memory, and emotion is an electric current passing through billions of neurons. Each nerve impulse lasts only 1,000th of a second and emits faint electromagnetic waves, vibrating at various frequencies. Beta 14, 30 Hz. Focus and active thinking. Alpha, Tamui high, relaxation, meditation. Theta and delta is less than 8 Hz. Deep sleep. These waves are, in essence, vibrating energy within the brain's electromagnetic field. When you think, the brain literally glows. Faint light has been detected within active neurons, a phenomenon called biophoton emission. This shows that consciousness is not merely biological, it is a highly organized form of energy, bridging matter and the electromagnetic field. When you sleep, that energy doesn't vanish. It merely shifts state, from conscious activity to restoration, like a calm ocean before sunrise. When a star exhausts its fuel, it may collapse into a black hole or explode as a supernova, spreading heavy elements like iron, gold, and carbon, the very materials that later form planets and your body. The light energy of that long-dead star is still traveling through space, and perhaps a photon born 10 billion years ago is passing through your eye right now. In the universe, there is no real boundary between life and death, only the exchange of energy. Matter dissolves into energy. Energy condenses into new matter. It explodes. It reforms. That is the breathing cycle of the cosmos. Physicists today believe that only 5% of the universe is ordinary matter. 27% is dark matter, and 68% is dark energy, a mysterious force causing the universe's expansion to accelerate. We don't yet know what dark energy truly is, but perhaps it is the very foundation of existence, the ocean of energy in which all realities float. Einstein once added a constant to his equations called lambda, the cosmological constant, to represent a pressure that keeps the universe stable. Later, it was realized that this might in fact be dark energy. The universe is not empty. The space between stars is filled with energy. We are simply not yet sensitive enough to see it. Every thought you have, every emotion you feel, is energy being created, radiated, and merging into space. A smile emits a faint electromagnetic wave. A word releases a vibration through air. A single gesture stirs billions of air molecules. When you exhale softly, that breath carries energy, travels through space, and will never truly vanish. Everything you do, no matter how small, leaves an energetic trace in the universe. When the human body ceases to function, its biological energy does not disappear. It disperses into the environment, heat into the air, molecules into the soil, the final photons escaping into the cosmic background. Every bit of energy that once was you continues its infinite journey, becoming light, wind, dust, or the heartbeat of another living being. So, in the language of physics, death is not loss, it is transformation. From electrons orbiting atomic nuclei to neutron stars spinning in galaxies, every motion follows a single rhythm, the exchange of energy. When energy is balanced, the universe is still. When energy is uneven, the universe changes. That imbalance is what creates life, time, and evolution. Every civilization, Every star, every human thought, is simply a different way for energy to organize itself, to become aware of its own existence. And perhaps our consciousness is the highest form of energy becoming self-aware. We are energy, momentarily aware of itself. Close your eyes. Take a deep breath. Feel your heartbeat. That is electricity coursing through cardiac cells. Feel your breath, chemical energy shifting in your lungs. Feel your thoughts, neural energy vibrating through your mind's field. All are connected in an endless circulation, from distant photons to your body and from you back to the universe. No beginning, no end, only energy alive, moving, remembering. When the universe was born, it didn't just create matter and energy. It created memory, the first traces of existence. Every photon emitted from the Big Bang is still traveling somewhere in space. Every atom in your body still carries information from billions of years of history. And at the deepest level of reality, all energy, whether light, matter, or thought, leaves an indelible imprint on the fabric of the universe itself. According to the principle of energy conservation, no energy is ever lost. But what few people realize is this: every form of energy carries information. When you light a candle, the heat, light, and rising vapor carry the microscopic structure of that flame. Each photon, leaving the candle, still contains information about the temperature, color, and motion of its atoms. Energy doesn't merely move things. It records the shape of the process itself. In information physics, this is known as the principle of information conservation, a concept emphasized by Stephen Hawking in his studies of black holes. Information never disappears. It only changes form. Even when energy dissolves, its informational structure remains engraved into the fabric of space-time. Physicists call this idea the holographic principle. It states that all the information contained within three-dimensional space is encoded on a two-dimensional boundary of the universe, just as a hologram contains the full 3D image within each small part of its surface. If this is true, then the entire universe is a vast hologram of energy and memory. Every photon, electron, and gravitational wave is a bit of information within that grand map. This isn't philosophy. It arises from string theory and the work of Juan Maldacena, 1997, who demonstrated that a universe with gravity can be equivalent to a quantum field existing on its boundary. In other words, the reality we live inside is the memory projected from the edge of the cosmos. Your body is not a separate structure. It is a continuation of cosmic energy expressed as life. The carbon in your bones once drifted through stardust. The oxygen you breathe was once trapped photons within the sunday. The iron in your blood was forged in the core of a supernova. When you touch your heart, you are touching matter 4.6 billion years old. Every atom in you carries the memory of ancient stars. It remembers the temperatures it endured, the frequencies it vibrated at, and its place within the cosmic flow of energy. In other words, you don't just live in the universe. You are the way the universe remembers itself. When you recall something, your brain doesn't take a photograph of the past. it recreates the same energy pattern that existed then. Billions of neurons fire again, in the same sequence, replaying the symphony of past energy. That's why memory is never identical. It fluctuates around the center of its original energy field. In neural physics, memory is a configuration of electrical energy. When you love, grieve, or hope, that energy doesn't remain confined to your brain. It radiates weak electromagnetic waves into the surrounding field. And if all energy is conserved, then, in theory, every memory, personal or cosmic, still exists somewhere within the shared energetic field. In 1965, scientists Arno Penzias and Robert Wilson discovered a faint radiation spread evenly across space. The cosmic microwave background, the lingering echo of the Big Bang. That light has existed for 13.8 billion years, and it still passes through you at this very moment. Every photon of that radiation is a real memory of the early universe. When you listen to its faint hum, you are hearing the first echo of time itself. It is proof that the universe does not forget. It preserves every transformation that has ever occurred. From the collisions of primordial particles to the beating of your heart right now. In quantum physics, every particle has a quantum state, a description of its position, spin, momentum, and energy. When a particle interacts with its environment, that state changes, and the change leaves an imprint on the surrounding system. For example, when a photon is absorbed, it leaves an energetic trace within the atom that received it. That information does not vanish. It merely disperses into a larger system. Physicists call this quantum decoherence, the process by which energy dissolves into the background, yet retains the microscopic memory of its original state. This demonstrates that every event in the universe leaves an energetic fingerprint at the quantum level. When a living organism dies, the chemical energy in its cells is released, transforming into heat, sound, light, and molecules. But the information within that structure, the DNA, molecular vibrations, electromagnetic waves, remains imprinted on the environment. Much of human DNA has persisted for hundreds of thousands of generations. Each cell carries the evolutionary memory of ancient ancestors, encoded in the sequence of nucleotides, one of the most durable forms of information storage nature has ever known. From the standpoint of physics, death is simply the diffusion of memory into larger space. There is no end, only memory returning to the shared energetic field. Many physicists and scientific philosophers, from Schrödinger to Wheeler, have asked, does the universe know itself? John Wheeler called this the participatory universe, a cosmos where the observer is part of the act of creation. When consciousness observes, it organizes energy into specific form, and that very act of observation records new memory into the universe. This isn't mysticism. It's a consequence of quantum mechanics. Observation collapses the wave function, creating reality. If every observation generates information, and information can never be lost, then every thought, emotion, and perception is a real memory of the universe about itself. Now, imagine the final moment of the universe. When entropy reaches its maximum, all motion ceases and no energy gradients remain. At that point, Energy no longer flows, but it still exists, not as heat or light, but as pure, silent information, eternal and still. Some physicists, such as Roger Penrose, call this the conformal cyclic cosmology, CCC, a model where the universe never truly ends, but is reborn from its own balanced energy state, beginning a new cycle of space and time, meaning every ending is simply the beginning of a new memory. Close your eyes, take a deep breath, feel the air moving through your lungs. It was once the breath of a star. Feel the blood pulsing in your heart. That rhythm is the ancient energy of the universe still beating. In silence, the vibrations within your body align with Earth's 8 hertzes. Resonance. Every cell begins to synchronize, returning to the primordial frequency, the one the universe uses to remember itself. In that moment, you are no longer the one listening. The universe is listening to itself. No more time, no more distance, only energy, light, and memory merged as one. Nothing ever truly ends. Energy remembers, and in its memory, we live forever. Now, everything is calm. You no longer need to think. No more footsteps of time. What you have just heard about light, energy, and the memory of the cosmos are only small words to describe what the universe has been whispering for billions of years. Through your very breath, let your body dissolve like morning mist, so that every cell may rest. Your breath slows like the distant waves, touching the shores of the stars. Imagine you are floating through space, light as a speck of dust, suspended in a soft beam of light. There is no direction to go, no destination to reach. There is only you and the universe, breathing in unison. Every heartbeat you hear now is the echo of billions of years of evolution. Every breath you take in is the energy of a star that once lived, once died, and then returned. You are not a part of the universe. You are the universe, remembering itself through human form. If there is any lingering thought, let it drift away like smoke, like waves of light fading gently into the air. There is nothing left to hold. No effort, no striving, because you have arrived at the place where energy calls home. Inside you, every vibration slows, every particle of energy settles into the frequency of stillness. This is the moment scientists call equilibrium, and the ancients called peace. They are simply two languages for the same phenomenon, energy returning to itself. Outside, the Milky Way continues its slow rotation, the distant stars still breathe in silence, and Earth hums you to rest at 8 hertz, the heartbeat the universe designed for human sleep. Let your awareness drift away, like the final light leaving the horizon. There is no boundary between waking and sleep, between you and the stars. Everything is just a slow movement toward stillness. And if you are still hearing this voice, let me whisper one last thing. You are safe. The universe is still holding you in its arms, and even as you sleep, the energy within you continues to shine like a tiny star in an endless sea of light. Take a deep breath in and exhale. Slowly. Everything else, leave it to the universe. Now, everything is calm. You no longer need to think, no more footsteps of time. What you've just heard about light, energy, and the memory of the cosmos are only small words to describe what the universe has been whispering for billions of years. Through your breath, let your body dissolve like a thin mist, allowing every cell to rest. Your breathing slows like gentle waves, lapping against the starlit shore. Imagine you are floating through space, light as a speck of dust, suspended in a dim beam. There is no direction to go, no place to reach, only you and the universe, breathing together as one. Every heartbeat you hear now is the echo of billions of years of evolution. Every breath you take is the energy of a star that once lived, once faded, and returned again. You are not part of the universe. You are the universe, remembering itself through the shape of a human. If any thought still lingers, let it drift away like smoke, like rays of light dissolving into the air. There is nothing left to hold, nothing to force, because you have returned to the home of energy itself. Inside you, all vibrations are slowing, all particles finding rest in the frequency of silence. This is what scientists call equilibrium, and what the ancients called peace. Just two words for one truth: energy returning to its source. Outside, the Milky Way turns softly, distant stars breathe quietly, and Earth hums at 8 Hertz, the frequency the universe made for the dreams of humankind. Let your consciousness drift away, like the last light leaving the horizon. There is no line between wakefulness and sleep, between you and the stars. All of it is one slow motion towards stillness. And if you are still hearing this voice, let me whisper once more. You are safe. The universe is holding you close. And even as you sleep, the energy within you continues to glow, a gentle star among an infinite sea of light. Now then, take one more deep breath. Relax your shoulders. Feel your body melting into the cool expanse of space. A small beam of light, a warm, tender star, is blooming softly inside your chest. That light is you, the most peaceful part of the universe. It will remain there through the night, keeping your dreams calm and deep. And when morning comes, that light will open again, as the universe smiles through you once more. Tonight, you don't need to try to sleep. You are already resting within the universe's own dream. Everything else, leave it to the universe.